Hello, ladies and gentlemen, and welcome back. We're on question number 20 from the 2003 Grade 8 Gauss competition. So question 20 says, the letters G-A-U-S-S, Gauss, are written on 5 tiles, 1 letter per tile. If Amy selects 2 tiles at random, what is the probability that she gets 2 S's? Okay, so what are we going to do here? Well, I'm a visual person, so I'm going to first go to my notepad and actually draw out some tiles here. G-A-U-S-S. Okay. So, what can happen? Well, she's drawing 2 tiles. Nothing says she has to draw them simultaneously. So, let's suppose she draws 1 tile. She's got 5 tiles to choose from here. So, she's got 5 tiles for the first draw. And then whatever's left over, she's got 4 tiles for the next draw. And then she'll have picked her 2 tiles. Okay. So that means that we have 5 choices for the first one, 4 choices for the second one. So that means overall we've got 20 choices for first tile, second tile, but okay, hold on. While I stand by those comments, she doesn't care about the order in which she draws the tiles. She's not filling in slots in a particular order. She's not choosing first, second, or third, or anything like that. So let's think about it. The question's asking us for probability. And probability asks us, it's a nice calculation, number of events that we desire versus the number of possible events. Okay, so what I was trying to do there is trying to figure out the total number of possible combinations, total number of sets of 2 different tiles that she could have drawn. Okay, and that would have given us the bottom number of events total. Okay, so first of all, I noticed that there's only, instead we're going to go at this from a different way. Events desired, that's getting S and S. And there's really only one way to do that. Okay? If there were some distinction between the 2 of them, if this were the first S tile and this were the second S tile, we'd have a little something different. You could have the first one first and the second one second. There'd be a couple different ways to do it. But there's really only one way to get SS, and that's if you've drawn S and S. So now the question is, how many possible pairs of tiles can she draw? Okay. So that takes a little thinking. If you, by the way, if you know combinatorics, which some of you might, but I'm going to guess that a lot of you don't, because it's a grade 8 level contest. Combinatorics isn't something you see until later in university at best, and that's if you have a nice teacher or if you go to an enrichment program. But if you know combinatorics, you know we have 5 things. We're choosing 2 of them, so it's going to be 5 choose 2. It's got even its special notation, and that's 5 factorial over 2 factorial times 3 factorial. You know that there's going to be 10 events total. Okay, if you know combinatorics, and that's great. A lot of calculators even have. Does this one have? This calculator doesn't have combinatorics buttons on it, but which is odd because it's a TI 30 something. And I have another TI 30 something that has combinatorics buttons on it, but that's not important. But a lot of calculators will have a nice NCR button. It's often a function button, and it would allow you to do combinatorics and choose stuff really nicely. But let's suppose we didn't know that. Let's just try and reason our way through this. But for those of us in the know, in the back of our heads, we're thinking 10 events total. Okay, but that won't affect what we do. Okay. So let's suppose, how are we going to do this? So I want to count the number of possible just other pairs of tiles. So for the total number of pairs that can be drawn, okay, alright, let's suppose, let's count the number of S's we have. If 2 S's are drawn, we know that there's only one way to do that. You have to have both S's. Okay, so there's one way to do that. How about only one S is drawn? So one of the 2 S's is picked. So we have 2 possibilities here, either this S or this S, the first S or the second S. And then one of the 3 G, A, or U is picked. Okay, 2 choices, 3 choices, they're completely independent. So that should give me 2 times 3 equals 6 different ways to have only one S being picked by Amy. Okay. And now how about 0 S's? So that means we have one of these 3 picked. Okay. And another one. Okay, hold on. So let's say here we have G, A, and U. 2 of them are being picked. One of them is being left. So one of the 3 is left. And the other 2 form the pair. Either you pick the U first and then the G, or the G first and then the U. That constitutes the same pair. So that's only going to be 3 different ways. So we'll get 1 plus 6 plus 3. And that'll give us an answer of 10 different ways. So we have one event that's desired, the 2 S's being drawn, out of 10 possible ways we can draw things. So that's 1 out of 10 for our probability. And that should be D. Okay. All right. So not a bad question. I would think if you knew combinatorics, which let's make a little bit of a comment here about combinatorics. 5 choose 2 is the notation that we would use, and it's 5 factorial over 2 factorial. And this is the number of ways to choose 2 things from a set of 5. Okay? In general, you can have n choose k. You got n things, you're choosing k of them. That's n factorial over k factorial. And this is the most basic crash course just in choose notation. By the way, this factorial stuff is just x times x minus 1 times x minus 2, all the way down to times 3 times 2 times 1. Okay? So if I wanted to figure out how many ways I can choose 2 tiles, 2 of these little tiles, out of 5, I'd do 5 choose 2, which is 5 factorial, so that's 5 times 4 times 3 times 2 times 1, over 2 factorial times over 3 factorial. And we can do some work. These 3's and 2's and 1's are going to cancel out. 4 and the 2 will cancel out and leave a 2 on top, and we'll just be left with 5 times 2 divided by 1, or 10. Okay, so that's another way you could have done it, but again, that's combinatorics. It's a little more advanced. It's not expected. That's why this is a question 20. If it were, say, a Fermat or a Euclid question, you might expect this to be much easier, because it's reasonable that someone might have seen combinatorics and be able to do it really quickly. But this is question 20 because we had to sit there and think of ways, how are we going to calculate the total number of different pairs of tiles we could draw? And it took a little while. We had to think through it. But if you know combinatorics, and then maybe this is encouragement to learn combinatorics, and keep your eye out for things like that, like videos online and things like that to learn combinatorics, or just finding a textbook that has some of it, combinatorics would have helped us answer this question a lot quicker. Okay, that's question 20. Enough said. Let's move on to question number 21, which we'll take a look at. It's first question in part C. We're going to take a look at that in the next video. So thank you guys for watching, and I'll hopefully see you in the next video.